Go ahead and get started. You guys hear me okay back there? Good deal. Okay, my name's Kris Moore. I'm the founder of the PC-BSD project. I work for IX Systems, and today we'll be talking again about ZFS. It seems like there's been a lot of that. And first up, I feel a little awkward giving this talk, having Matt in the audience, but I just want to say thank you for ZFS. It has enabled us to do a lot of really cool stuff, some of which we're going to be showing today, how a cool underlying piece of technology like that can then be expanded out and do all kinds of fun graphical things and stuff that end users will really appreciate. So today, we're first going to answer the question, why ZFS? So a couple years ago, we made the decision we were going to move ahead with ZFS only as the default file system for PC-BSD, which is a desktop operating system. Naturally, we got a lot of pushback and flack. Well, why would you go all ZFS? I mean, it uses more memory, et cetera, et cetera. But we decided there's enough compelling reasons to do it. I mean, first of all, the benefits have just greatly outweighed the drawbacks for desktop usage. And after we decided to move to 64-bit only as part of that, that was pretty much the last major hurdle we had. At the time, FreeBSD 32-bit, and I think it still maybe was a little flakier when you're running ZFS, and I could kernel panic it pretty easy, so I didn't want to push that on everyone's box. But it just opened up a whole new class of utilities and methods and things that just weren't possible without it. So we really wanted to take advantage of those for the desktop user. And by the way, if you guys have questions or you want to interrupt me, raise your hand. I have no problem doing that. As a matter of fact, I enjoy chasing rabbit trails. But first thing we're going to look at today, one of the new technologies we added to PC-BSD is something called boot environments. So who's familiar with boot environments? Who's heard of this or knows what this is? Okay. We got a few of you guys here. Okay. So first up, boot environments first originated in Solaris 10. Is that correct, by the way? I pulled that from the net, and I assume that was the first version. Okay. So it provides a method of using ZFS snapshots and clones to pretty much create an instant bootable backup of a system. So most commonly, we would use this in the case of doing something dangerous. Say we're going to update your kernel world, or maybe even just update some packages, and I want to be sure that I don't lose a working Xorg on a desktop. So how is this done, though? First of all, we use Grub to perform a direct boot up of the FreeBSD kernel using the KFreeBSD functionality in Grub. We accomplish this with a special ZFS data layout, which I'll show you in a moment. And then we have a utility in FreeBSD called BEADM, which is just some shell scripts to kind of put all the pieces together, manage that. And then, of course, we wrote a GUI front end for this as well. So another question I always get, you're FreeBSD. Why in the world are you using Grub? Well, first of all, it's pretty much the only way we could do it at this time. The FreeBSD Loader didn't have the support and still doesn't quite have the support we need to do boot environments. And it was super easy to tie it into BEADM, provide all the menus, provide submenus to make a functional boot menu system. Also, it's what Solaris uses, so it was good enough for them. They obviously probably didn't want to write their own as well. So, and also in 2014, I mean, we're a desktop. I don't really see a problem with having a graphical bootloader. So, sue me, I like pretty pictures on my desktop. And it also loaded up the kernel and modules a lot quicker than the FreeBSD Loader did. So that was a bonus. A couple things not on the slides. It lets us do hybrid USB, DVD, ISO media, which is pretty cool. So it had some neat benefits. Again, if the license wasn't GPL3, I would be thrilled. But at the moment, that's the best we have. And until FreeBSD grows some of those options, we'll be sticking on it. So can you still use the BSD Loader? Yeah, of course you can if you want. We provide the option. It just doesn't have integration with boot environments. So if that's a mission critical feature for you, then you're going to want to stick with the default, which is Grub. And as I said, we will eventually switch back to the BSD Loader. We've been doing some work. I've been talking to Devin Teskey, who's done a lot of work in the loader space. We're hacking on Forth code and whatnot, which I don't envy him because I don't understand Forth at all. And at some point when he gets it to a workable stage, we'll look at adding that support back in. So how do we do this? How is the boot environment accomplished? Well, we do some unique stuff with the ZFS dataset layout. So by default, on a PC-BSD box or a server box, doesn't have to be a desktop, we're going to create some different data sets. You'll end up with your main tank 0, which is our root pool. Then we create a subset of that root, and then /default is our first data set, which is pretty much going to be everything on /. Every new data set is going to be snapped or cloned from this for boot environments. So we have any additional data sets that are created on the system are not going to be included in the boot environment, so you got to keep that in mind when you start creating data sets. You'll need to find some alternate method to snap those. That's not going to be a part of the boot system. We do create a user and var data set but we set the can mount flag to off just because we're using those as placeholders to create other data sets on top of them. But we want user included, we want var included. We even go so far as to include user local in the boot environments because, again, for a desktop user, it's just as critical having Xorg come back up as it is having a kernel module load or something. Those kind of go hand in hand. If my desktop users boot up their system and they just end up at a text prompt, that's of no use to them. So on a typical install, you'll end up with just a variety of different data sets. You can see here we have some user data sets, but those guys will all be excluded. So your home directories are kept outside of a boot environment. Any jails are kept outside, ports, dist files. We have some directories in var we keep outside the boot environment as well. A cool thing this allows you to do is you can even do kind of a Franken system, like, I don't know if Alan Jude's in here, but if he is, if you see him somewhere, have him show you his laptop. So what he did is he took boot environments, had FreeBSD 10 on it, and then created a boot environment and put current on it. So he can boot between the two, and he's sharing home directory data, he's sharing some different directories between them, so he can just kind of toggle which one he wants to boot. So how do you manage them? So if you're a command line user, you can use the beadm command. When you're creating and removing BEs, we've done some work to tie it into Grub, so it'll automatically regenerate menus and set it up for you. You don't have to know or care what it's doing in the background. Using the command's pretty simple. You can do a beadm list, and it's pretty much going to show you, ZFS snapshots or clones there. And then when you create a new boot environment, it's going to generate a new Grub config, which I'll show you a little bit of that here in a moment. And then when you're done, you can list it. You now have a new boot environment. Because it's based off of ZFS and we're doing a clone, it's not really using any additional space at this point until the file systems start to diverge. So I can create them instantly, and they're cheap to create, which makes it a perfect candidate for when we do online updates. I can create a boot environment instantly beforehand. If something goes sideways, the kernel doesn't copy properly, whatever, no harm, no foul, just boot into the old boot environment and you're set. So via the GUI, we even have utilities which will allow you to create, add, or move boot environments graphically, which is handy again for some of our users who aren't really skilled at the command prompt. We even have a Grub configuration tab where you can load your own themes. You can add custom entries if you want to boot Linux or Windows or whatever. We can do that for you as well. So how do you boot it? So when you install a PC-BSD 10 box, by default, you're not going to see any menu at all. You'll have this real short little message in the top left-hand corner that says hold left shift to view menu. We put that in just as a nicety because if you're only booting one OS, you don't need to be taken to a menu every single time. Maybe a little more Mac-ish in that way, I guess. But you hold down left shift, and then it'll pop up the menu and show you which boot environments are there. And it'll look something like this. So as you see, we have our default, and then we created the newbie boot environment here. So we could boot back into that, and Grub will essentially load that kernel from that data set, set the VFS mount root to the other data set, and you're good to go, able to boot up. So customizing. We can, of course, customize Grub menus as well. If you're not familiar with Grub, if you're a Linux user, you probably know some of this already, but for a lot of FreeBSD guys, this was new to me when I started hacking on it. You have a user local etc default Grub, where you can set options and defaults. Anytime you make a change to Grub, you have to run the grub make config command and give it the output file, which will be boot grub, grub.cfg. When you run that command, we have some magic bits in there that'll make sure that config gets copied to each data set. So you can be sure that on one boot environment, you can update your config and still have those options available should that boot environment become unavailable at a reboot. And the grub config syntax is pretty much shell script. If you look at it, you go, oh, this is 90% shell, I get this. If you've ever done any shell scripting, it'll be pretty obvious. So some of the default options you can use for it, we turn on grub hidden timeout, and that was that option I was telling you about where you hold the left shift. You can set how long you want that to appear. You can set grub default, which is the default menu entry to boot. So say you have a system or a server and you've made a couple boot environments. You've set up, say, the third one with a new kernel, and you want to run that for a while, you could set that as the default. So if you reboot it remotely, it'll boot right into that third boot environment again. Of course, you can set timeout. Themes, again, if you're a server guy, you may not care as much about that, but for desktop guys who want their own pretty pictures, they can do that, set different fonts, etc. So that's kind of how boot environments work, but now we're going to look at the other side of that. So we've saved a working copy of your desktop, but what about all your other data? What about your data in your home directories, your jails? So we have a utility we created on top of ZFS for that called Life Preserver. So basically what it is, it's again a command line and graphical front end for scheduling ZFS snapshots and pruning, scheduling ZFS sending and receiving, replication, does Zpool monitoring to alert you if something possibly is going wrong where you want to take a look at it. And it also provides a mechanism for doing bare metal restores. Should the worst case scenario happen, your system, my laptop gets stolen, well, I have a copy of it back at the house, so I can just go buy another one and restore it right back to where it was at the time of the last replication. So how do you get this utility? Well, it's obviously included in PC-BSD 10, and we also have it available in the FreeBSD ports tree. So, and also if they've updated package NG recently, they'll have the most recent copy of that. It's under sysutils, PC-BSD utils, that's for servers. So if you want just the command line stuff, that's the way to go. But if you have a full-blown X installation, you're rolling your own laptop or desktop, you can grab the Qt4 front ends as well. So scheduling snapshots. So from the command line, it's actually pretty simple. We can just use the L-preserver command for everything. There's a bunch of sub-commands within there. But in this case, we're going to say, I want to enable cron doing some snapshots of tank 1. Everything by default's recursive, so you only have to give it the Zpool. We're going to start them. I want to do them, say, daily at 2200. And I want to keep 10 of them. So that's kind of the syntax on the command line there. And of course, you can replace daily with a bunch of different options, hourly every 30 minutes, every 10 minutes, every 5 minutes, and so forth. There's a variety of different things you can do. And of course, 10 would be the number you want to keep before you start automatically pruning them. So what does this command do? Well, essentially just creates a cron entry, which is going to point to our script, point to the tank that we want to do the snapshots of, and how many of them we're going to be keeping. The rest it stores in VARDB in its own little database. When the script is run, it's going to do a few things. First of all, it's going to confirm this Zpool data set is still there and working, and we're not trying to do this on an invalid target, of course. It's going to then create the snapshots recursively throughout the entire Zpool. It'll then go through and see if we have to do any auto pruning, maybe of old snapshots that have expired or anything that's beyond the limit the user set. It can also send out notification emails, so if you've enabled that, you can get a notifier that it either worked or failed or there's an error, something you need to look at. And it can start the auto replication if you've enabled that. So from the desktop, we have a graphical utility that'll do that. When you start it up, it's empty. There's no pools being managed. So we're going to go, let's manage my pool. It's going to list tank in this case. It's going to ask you what's the schedule you want to set up, and we'll say daily at 1 a.m. How many days do we want to keep, or how many total snapshots? So it'll figure out how many you need. And of course, replicating. So we can replicate your data. And a cool thing is, we can, on the GUI, we can scan the network looking for MDNS entries. Like say there's any SSH servers advertising on the network, we can just list them. You can click and say, there's my backup server. You can enter username, different ports, and then the remote data set you're going to replicate to. And of course, we can set a frequency. So you can do it with at the time of snapshot creation, which works good if you're doing maybe dailies, or if you just want to set a specific time, like do it at noon every day or midnight or whatever, you can schedule that right here. So a little thing that got added this last week, though, we added a new automatic mode for snapshot scheduling, which is pretty cool. It's what I'm using on all my boxes now. That just went out in the 10.01 PC-BSD update, and it hit the ports tree a couple days ago. And what that basically does is it'll create snapshots every 5 minutes, which are kept for an hour. And then an hourly snapshot will be kept for a day. A daily snapshot will be kept for a whole month. And then a monthly snapshot will be kept for a year. So very user-friendly. Via the GUI, it's like automatic, finish, done. You don't have to set anything else. It just takes care of it. In addition to that, though, well, what about disk space? So the daemon's going to keep track of all your Zpool disk space. So if the capacity hits 75% or some other value we decide to set, it can start auto-pruning those oldest snapshots to recover some of that space for you. Now, the cool thing about Life Preserver is it won't auto-prune any snapshot you've created manually. It only keeps track of its own, because I don't want to trash something you've specifically set aside. That's up to you. If you're smart enough to create it, you're smart enough to delete it, is my thinking on it. But of its own stuff that it's creating and managing, it'll do the automatic pruning for you. So email notifications, again, very simple to set up. You'll just use L-preserver set your email address. It's just going to use the mail command, so we're going to assume you have mail set up on the box. We can set, there's some additional commands such as disk usage warning. So if you want to be warned when you hit 70% capacity, you can pop that in there and it'll check every 5 minutes and warn you if your pool is starting to get low. Additional commands, email options. I don't like getting all my messages, so I just set it to warn, so it'll only shoot me an email if there's something it thinks might be concerning, such as disk usage, or if there's just a flat out error, replication failed, snapshot failed, etc. So you can toggle that for the amount of gory detail you want. So replication though, once the snapshots are enabled, I mean, that's super easy to do, but replication's kind of where all the rubber meets the road here. So replication, you may set it up to run automatically or at a specific interval. By default, it's gonna run over SSH, so we'll need access to a remote SSH on another box, and it's gonna use ZFS send and receive. So in this case, it'll require the target have the supported ZFS version that you're running on. That can be another operating system, I don't care. As long as it's capable of receiving ZFS snapshots from whatever client you're on, then you should be good to go. The way I do it at my house, I have 5 systems. They all snap to a FreeNAS box, which sits under my desk with a bunch of mirrored drives in it. It works really well. So how do we start that? Well, first of all, you're gonna need to prepare the remote system. So we start by creating a new ZFS data set and then an SSH user, because I don't want to SSH in as root for obvious reasons. And then we're going to set some ZFS allow properties on that new backup data set that we want to create. So we'll have a list of properties we're going to set here. And then on the clients, we're just going to go ahead and start the replication. So we're just going to say replicate, let's add my host, my username, port number, which data set or pool we're replicating, and then the target, which will be the remote pool / whatever the new data set is, and then the mode. In this case, I chose sync, which is do the replication and keep it in sync with the snapshots that are taking place on my box. And of course, you'll just replace those host user port numbers with whatever your system is running. So how does this work? Well, first of all, when replication kicks off, again, it's going to run some checks, make sure everything's hunky-dory with your Zpool. It's going to then look for some properties we'll set on the Zpool. It's going to check for when the last replication was done, if we've already marked that we've replicated up to a certain point. Based on that, it's going to either then do a first time or full replication of the entire Zpool, which can take a while depending on how much data you have, how fast your wire speed is, or else it's going to kick off an incremental saying, okay, we only need to do this many snapshots from the last one which was done. It'll start the ZFS send and receive commands. And then when it's finished, it'll just update those flags, setting the backup life preserver property on whichever the last snapshot replicated was. When it's done, it'll do a couple extra things. It'll build a complete list of your entire Zpool dataset options. And we want to keep that list for a couple reasons. So we're going to keep this list and save it off to the remote system. And we use that for bare metal restores and making sure we pull and set all the right properties back when we do a recovery. And then, of course, if email reporting is enabled, let's go ahead and send out notifiers saying, hey, I've replicated, or hey, this didn't work, please check it. So a couple notes on this. Of course, first-time replication can take some time. You're sending your entire disk over the wire, so that can take a little while. During replication, new snapshots can be created, but the auto pruning is automatically turned off. So anytime replication's running, we're not going to be screwing around through snapshots until we've had a successful replication take place. And if the replication fails, it may be required to reinitialize the remote side. Matt kind of touched on this in his talk a little bit about getting the resume support. So that's something we're looking forward to very much. Once resume hits, we can make that a little nicer. But should it fail, say my laptop dies in the middle or I've lost Wi-Fi connection or something, which has happened, I may have to reinitialize the remote pool. So the way I would do that is with the lpreserver command, the replication, and initialize whichever the pool name was. It'll set it back up to roll again. So once the snapshots have been created, there's going to be a bunch of ways you can pretty much revert or restore files. So via the command line, you can just run lpreserver, revert the snapshot, give it the data set, the snapshot you want to revert, and away it goes. It'll handle all that recursively for you. Additionally, you can, of course, browse files in the mount point for that data set under the special ZFS directory. But of course, getting stuff back via the GUI is just a lot more fun because it's point and click and I don't have to type out long snapshot names with timestamps in them. So let's take a look at what that looks like here. So in my life preserver utility, I've gone ahead and set up my tank 1. It's snapping, doing it all automatically. I can then go to the Restore Data tab, and I can choose my data set up top, which in this case may be my home directory. And then you end up with the slider bar where you can go back and forth in time and say, okay, this is what my directory looked like last week. Find the file you're looking for, and you can show hidden files if there are any. And then just hit Restore on it. It'll bring either that file or directory back to your working system. I think it names them .backup or something like that. But it'll pull them all right back for you, and away you go. This is simple enough my dad can use it to find a document or something maybe he accidentally deleted a couple days ago. So how about bare metal restores? Well, starting in PC-BSD 10, the install DVD or USB media that you download from the website can also provide a full bare metal restore functionality, which is pretty stinking cool. I've had to use it a couple times already because of mistakes or boo-boos or hardware going south. But it's currently limited to the graphical installer, but we have a text installer that we started on a couple months back, and it'll be going into that here in the near future as well. It also allows you to adjust and change your Zpool options on the fly. So what does this look like? Graphically, when you start up the installer, you get three options. You're going to install a desktop, a server, or we're going to restore from a backup. So we've picked Restore in this case. It's going to prompt me for the host name of the box, username, SSH port. When you click Next, it'll then either ask you for a password or ask you to provide an SSH key if you have one on a USB stick. It can save them there as well. It'll then interrogate the remote server, ask which systems have been backed up to it, because you can have multiple systems backed up to the same SSH username. So in this case, all the host names are listed. I want to pull back, we'll say Executor, one of my boxes at the house. And then it's going to take me to the disk screen, just like I'm doing an install, except in this case, it's going to tell me that the original ZFS layout is going to be restored. And then when you hit Next, away it goes. That's pretty much it. It's about a 1-minute process if you want to start a bare metal restore. But if you hit Customize on the disk, you can still go through and set some disk options as well. So say I've done a system, it's on, we'll say 1 disk or whatever, and it's a small disk, and I'm getting ready to replace it and go to RAID Z or something fun like that. I can replicate, and then I don't even have to shut the other system off. Just pop the disk in the other system and say, let's pull this data back, walk through the wizard, and maybe we'll enable mirroring or RAID Z mode on the new system, and it'll just handle all the setup of that. And then when it's done, it's going to tell you it's going to automatically restore the same data sets. We're not going to change those. But as far as Zpool options, yeah, you can have at it and make any changes you want on the fly. So how this works is it uses the PC sysinstall installation backend. That's a backend we wrote for PC-BSD a number of years back. I've given some talks on that. Everything's a fully scripted install. So every single install or restore, anything you ever do with that piece of software is fully scripted. And now, starting in 10.0, it supports the ZFS Restore method. So it'll just allow us to pull from a ZFS replication. So you can use this for system deployments, cloning. I mean, it's just basically another installation target saying this is the source we want to pull from, as opposed to DVD. And it's going to use SSH as the transfer agent again. And it uses just pretty much the normal PC sysinstall disk setup syntax. So what does that look like? In this case, I've done a restore, and we only have a few lines of code here. But I've just set the mode to ZFS Restore. I've set up maybe my host name, username, port, pointed at an SSH key I imported off a USB stick. The properties file is that file I told you where we save, the life preserver saves a list of all the data set properties. So we're going to point it at the properties file for this restore we're doing. And then the remote data set we're going to be replicating back to our box. So what about ZFS Mirroring? Because we wanted to do some fun stuff with there too. Again, ZFS has such cool things it can do that, 5 years ago, man, I wish I had some of this in 8.0. But anyway, we have it now. I'm really thankful for having this. But in addition, you can set up mirroring. You can do single disk. You can set up RAID Z. Life Preserver can attach these new disks using the Zpool Attached commands for you. It doesn't do much more than that, except it goes through a few other steps here where it wipes partitions on the new disk. It'll create matching GPT or MBR partitions, so your new disk will align with your old one properly. It'll then make the disk bootable with Grub. So as soon as you insert that into the pool, you can reboot off it, and then it'll begin the restore process. So once that's done, you're good to go. So that's pretty much the end of my prepared talk. I have a reference here to my PC sysinstall talk from 2010 where you can find out all about the syntax, how we did some of that stuff, and then a link to the slides. So are there any questions? Yes? No, it's not. I don't believe so. It was a rewrite done by one of the guys in the FreeBSD ports team. He just re-implemented it in shell for FreeBSD. But then we took that and hacked on it and collaborated a bit and ended up with something that did all the grub magic to do the actual boot environments. If you download BEADM from the ports right now, the way it works is without the grub component, you can create a boot environment and then you can set it to boot it the next boot up. So it requires that you're on a working system, then you say, okay, I'm gonna reboot, but I wanna boot into this environment next time. That's great, but that doesn't fix something. Say you crash and that boot environment's gone and you can't boot up at all, you have no menu to select other ones. So we added that messing bit with the grub menus. Yeah, Jim. Okay, so the question was, what's the minimum you have to have installed if you're going to be using all these life-preserver utilities? Because PC-BSD lets you customize everything from desktops to packages all during installation. So actually, you can do like a 300 meg install. If you do TrueOS, that just gives you the command line versions. All that stuff's written in shell, so no dependencies. It's just really cheap and easy. If you want to do a quick, easy desktop, it's included in any of them. So you pick any window manager. I don't care if it's OpenBox or Fluxbox or Rat Poison or whatever tiny one you want, and you'll still get those utilities installed. They're just a package. The only dependencies it's going to suck in are the Qt dependencies it needs to run. But you know, that's a couple hundred megabytes, I think, by the time it's all said and done. Yeah, same commands, same user interface. We standardized all of our tools on the Qt library so that it would look identical no matter which window manager you pick, because I may like KDE, I like XFCE, you may like GNOME 3 or Cinnamon, or take your pick. Everyone has their flavor, and sometimes you change between them, but our tools will stay consistent looking between them. Any other questions? Yeah. To manage their servers? I couldn't name names off the top of my head. We've had people mail to the mailing list saying they're using it. So on TrueOS, they're using the command line version, so they must be doing something from a server. But yeah, I don't know names of companies who are necessarily using it. I would hope more people are using it. This is still pretty new. Most of this stuff just went in about 3-4 months ago. So, I mean, it's still under pretty active development as well. Mm-hmm. It's okay, so interesting thing about that, it's in FreeBSD already. If you go to the ports tree under sysutils, PC-BSD-utils, it's included in that. That's just the command line utilities. This is actually kind of cool. So for years, we've been doing PC-BSD, and we've been porting stuff from Linux and trying to catch up to Linux, and oh, we need this from Linux. This is the first utility we've written where the Linux guys are like, yeah, could we port that to Linux? This is really cool, because now ZFS on Linux is coming out. So yes, this could be ported to Linux. It's using ZFS commands, so it will probably run pretty darn close to how it does on PC-BSD. OpenBSD, well, if OpenBSD grows ZFS at some point, yeah. And they've even requested to port it to Btrfs for some odd reason, which I was like, have fun with that. That's all on you, dude. But anyway, so we've had requests come in for that, so I imagine you might see it in some other places here in the near future. Cool. Any other questions, guys? Okay. Well, thank you guys for listening. Oh, and stick around. Drew